Well, thank you for the opportunity to present our project. Can everyone see the presentation? Yeah. So this is an open source project. We don't sell anything here. This is for you to use if you find it interesting. Everything's on GitHub, and if you have any question after this talk, you can always contact me, and I'm always happy to help people understand better how to use it. Maybe just a few words about the team. So this is the manager who gave us the opportunity to build this project for Nav, and then those are the engineers who have contributed. I've coded kind of the code generator for it, and we've been working together to kind of productize it, and it's running in production now for about 6 months, and it's delivering what we were expecting to, which is help us manage the validation rules in payloads in microservice architecture. A couple words about me. So I'm an enterprise architect at Nav. Nav is a small business lending platform. We kind of help small businesses find financing, credit cards, small business loans, etc. And then we expanding in a few other areas in the finance industry. So I've been an enterprise architect for quite a while, also kind of flip-flopping between principal engineer and enterprise architect. I was for 3 years a principal engineer on SAP's GraphQL platform. So we built a very interesting platform that allowed developers to collaboratively work on the schema and with the concept of packages, and then deploy those packages in the platform that would include parts of the schema and resolvers. So that's, we stayed away from federation because it was not something that we had found useful for our project, and instead what we've done is we had given the ability for the engineers to craft their own areas of the schema and the corresponding resolvers and deploy that. So there's a big CI/CD pipeline related to that, so that we would test and whatnot. We wouldn't let just broken code or schemas being deployed. The platform, when I left a couple of years ago, was dealing with 400 million transactions per month. So it's a good sized platform. And as far as I understand, it's still running and delivering the value that we expected. So I'm a big fan of GraphQL, a huge fan. It didn't start it that way. I was quite skeptical back in 2016. I just thought it was a virtual memory type of technology, and I felt that has not succeeded in the past. It will not succeed in the future. Until I understood, at least the way I understand GraphQL is for me an API orchestration engine. And once I started to look at it that way, and taking the role of dealing with all those API orchestrations to the back end, something that the front end engineers would have written in the past. This API orchestration code is hard to write, hard to debug, hard to maintain, and GraphQL solves that problem elegantly. I mean, it's so elegant as a technology that it hurts. I've rarely seen something so well designed in my career, and I'm a huge fan, as you can tell. So again, what do we do is small business lending. I introduced about 10 years ago the concept of service as a software. So it's a play with word. I know that SaaS means software as a service, but it's a play with words to say that you can also read SaaS the other way, and you can take physical services and expose them as a software, as an API, that other software companies can deal with. So software as a service is mostly kind of a licensing mechanism, maybe cloud, etc. But here it's a little bit more profound. It's really about taking a given physical service that would have existed, maybe thousands of years ago. Small business lending has probably been around for a long time, and take this physical service and reason about how you expose it as a software so that third-party developers, partners, etc., can integrate it in their own software. So that's kind of the platform that we built. We manage, insights. We collect a lot of data legally, and then we create insights from there. We decide whether a particular user of the platform is a lead, and then we facilitate writing applications to lending, credit card partners, etc. And then, as I mentioned, our platform's APIs are invoked by partners such as Clover, which is a public partner, and we have a few others as well. Our stack is pretty standard, React, GraphQL, Golang. We have, a little bit too many languages in the backend. Golang, Elixir, Ruby, Python, and then we try to stay with Progress as much as we can, and we use, of course, Kubernetes. So there is not represented here huge machine learning aspects that we're developing and using to help us in all our processes. So that's in a nutshell what we do. So now let's look at nav schema architecture. So the problem is we introduced EvenBridge, EvenBridge is AWS EvenBus, to kind of replace gRPC integration for create, update, delete. The team, before I joined, had kind of focused on synchronous interaction, and those interactions, this type of interaction is not, is really not advised for any kind of side effect, because as soon as the system is down or there are glitches, you're really going to create inextricable problems for your data, and your data quality is going to suffer and whatnot. So we introduced EvenBridge, and as part of doing that, the big question became, well, how do we validate payload, event payload, but also, API payloads and whatnot. When you use gRPC, you use protobuf, so that's a form of validation. And now that we had all those languages in the backend, all those interactions, how could we make sure across microservices that our validation rules were consistent? Because, let's say you publish an event, you probably want to validate the payload just to make sure that there is nothing, troubling when you create the payload and you're ready to send it. And then, of course, when you receive a payload, you want to make sure that, before you start processing it, that this payload, is valid from a number of rules. And when you look at all this code that would have to be written in a typical microservice architecture, again, that code is kind of annoying to write. But what's important is that it's very hard to keep consistent across languages. Who knows if the if then else here in Ruby is going to match my if then else over there in Golang. And so this is the type of code that developers generally don't want to write. Impossible to maintain, because now you have two teams that synchronously have to change those rules, and very quickly, you kind of lose track of it, and you just give up and you don't validate as much as you would wish to validate. So this is the problem that we address: is how do we create validation code that runs both on the server and the client to make sure that the payloads that are exchanged, either via events or just simple, HTTP requests, are valid from a number of business rules. So you can tell me, well, there's been schema languages. What happened to that? Well, I was there. So I started my career with DTDs. You probably never heard of it for some of you. I was actually around XML-schema, and I can be credited for having killed the SOX proposal. SOX stand for schema. What is it? Schema for object-oriented XML. So somebody had the idea of putting a class structure on top of XML, killing all the extensibility mechanism that you can have with XML or JSON. And so I was credited for building the whole reasoning around not doing that and keeping extensibility mechanism in XML schema. So the any element is something I can brag about. Not because I put it there, but because I defended it, and it kind of made it through the proposal, and still it still is there. So there you have all those schema languages, and I don't know if you ever worked for a company or if you yourself have developed a large body of schemas. It's typically a technology that's in the corner and people don't touch too much. But if you did, most likely you ended up in a corner where pretty much all the properties in your schema become optional. In other words, if at some point you decide, all right, I'm going to write a schema, and you take the decision, oh, by the way, all the properties in my schemas are optional, it means that your schema architecture is not working. And that's pretty much why those schema languages are not used widely, because they're broken. Even Google, I mean, you look at Protobuf, you look at a company the size of Google, the brand power that they have, and you look at Protobuf v2 and Protobuf v3, and they couldn't deal with the optional required problem. They had to give up. They just say, all right, we will make everything optional. So even Google couldn't, and it's something that is very structured, like Protobuf, much more structured than XML schema or JSON schema, couldn't deal with that problem. So nav schema architecture deals with that problem, I believe, very elegantly, but I'll let you judge that. And this is essential if you want to validate payloads, because what is the point of validating if your business rule is everything is optional? Because we know it's not true. Parameters are now optional. So this is kind of where nav schema architecture plays. It's a replacement for those schema languages, and it's a replacement that will solve that problem and a few others. So the other problem that you would face in creating a schema architecture is how can you reuse data types? Because when you have large teams, multiple microservices, of course, data elements are reused across, not just an interaction, but across many interactions. And again, that problem was never solved by the schema languages. And some people have created patterns that you probably have never heard of. I know those people personally. They're kind of friend of mine. They spend a good chunk of their career on schema languages and creating schemas. And they came up with those patterns, the salami pattern, Russian doll pattern, Venetian blind pattern. And basically the idea is to slice and dice, your business entity into little pieces that you can recombine in a payload, because that's the only way. There is no other way, like inheritance or, things like that will not help you say, hey, look, I take this data structure and, in the payload, this data structure looks like this. There is no semantics for that. So the fundamental problem, the reason why those schema languages don't work is because, well, you can create data model with XML schema or JSON schema, just like you could do with GraphQL schema. That works. You can create message payload schemas with XML schema and JSON schema, but you cannot do both at the same time. And that's kind of the genius of GraphQL here one more time, not just that the kind of problem they solve, the engine design, the genius is they realize that, if you want to define a payload in relation to a schema, you need a projection language. You need to say, well, out of this data structure here, what I want to do is pick this, pick that, and I want to assemble it like this. And once you state it that way, then you realize, geez, I could somehow use GraphQL as a domain-specific language and say, and therefore as a schema language, and say, all right, forget the runtime. There's no runtime in this project. I'm just going to use the syntax of GraphQL, the semantics of GraphQL, and I'm going to generate code from the schema, the GraphQL schema, and the queries. And that code is going to help me validate payloads. That is as simple as this project is. It's not rocket science, but it is addressing a very old problem. DTDs have been around since like early 90s, I think. Before that, there was EDI, who had a different kind of mechanism to validate data, a little bit like protobuf, basically. And for, say, 30 years, that problem has remained unsolved, literally, and now you take GraphQL and all the semantics of GraphQL, you add a code generator to it, and all of a sudden you have a solution to that problem, and you can generate validation rule across an entire microservice architecture with minimum work, with as little work as you could think, I think, personally. So just to illustrate the problem, again, and for people who are familiar with GraphQL, this is kind of bread and butter. You have a data schema here, then you have payloads here. And as we know, things are kind of picked up from different entities and end up in the result set that we get from the GraphQL engine. So nothing amazing. I'm sure you're all familiar with those concepts. But now what we can do is we can take GraphQL schema as the DSL. We can take the query language as a DSL. We can create our data model, just like we would do for, if we were using the runtime. We can create our query, but this time they're not queries anymore. They are message payload definitions, as we're going to see. And then from those two, set of files, I can generate anything I want. I can generate protobuf, Ruby, Python, Golang, JSON schema. That's what we generate today, because that's what our backend is. Writing a generator is about 250 lines of JavaScript, so it's completely doable if the language is not in this list. If you want to create a Java generator, I can give you a hand if that's something you're interested in. But it's basically 250 lines of code on average. It's a little bit more, a little bit less, but it's not 1,000, it's not 10,000. It's about 250. And JavaScript, it's all trivial, mostly templates, so it's nothing impossible. You probably would do it in a couple of days if the language is not in there. Everything else in the project is reusable. You don't need to change anything other than the code generator for your target language. So why did we choose GraphQL? As I mentioned, this is kind of the only DSL that I know of that has those two concepts tightly linked together: the schema, the data schema, and the projection of the data schema into the structure, kind of mix and matching attributes from different entities. As we all know, it has an exceptional developer experience with editors, viewers, parsers, etc. And that, I think that's what makes this project very appealing. We didn't create our own schema language. We could have, I've done it actually several years back in 2015, but I was not successful marketing it. simply because, yeah, it's yet another syntax to learn, and who knows, what's going to happen to JJ's project, product, whatever. And as opposed to here, it's like, look, you have a rock solid syntax, well known by everyone with minimum learning curve, and you can generate all this validation rule code that otherwise you wouldn't have. So what it means in particular is that if you already have invested a lot in GraphQL, you can reuse a lot of that data model to be the basis of your payload validation. So that's something that is also to consider. So at a high level, what does it look like? Well, here's a data model, here's a query. You're nothing earth-shattering that you wouldn't recognize. We have a little bit more directives because this is how we add metadata to the query language. If you're not using protobuf, you will never see the order property. It's just protobuf because it's a binary format. It needs you to tell in which order the property appear in the payload. But if you're not using protobuf, that field is totally optional, and it's nothing you would need. One of the key aspects of the solution here is that now we can overwrite required and optional. In other words, as we know, in a business entity, we have a lot of required parameters because that defines the integrity of the data of that business entity. But in a payload, it's completely different. Like an address, you could be just transferring the city of a customer because that's what the front end needs, right? So you don't need, the address to keep its integrity during the payload transmission. And therefore, that's kind of the beauty of GraphQL, is that now I can define a projection of a business entity, and I can still get the data that I want. And what's nice from a schema validation perspective is that now I can either reuse the required attribute here, or I can override it. I can say, well, I know that, say, ID is required, but in the schema, it's optional. In this payload, if I have the ID, I will pass it, or if for every other reason, I will not pass it, and it's still okay. The payload is still valid. So that problem is solved, and I feel that solves quite a difficult problem that's been hard to solve, for decades, literally. So what does the generated code look like? This is Golang. Sorry, I'm a JavaScript fan, so I always make fun of Golang because each time I see the JSON mapping syntax, it cracks me up that you have to put the JSON mapping in a string next to your type definition. But it's just me. But anyway, this is what the generated code looks like. There's validation rule, and I will give you more examples as I walk you through the code, so that you get an idea what the project look like, so that you can decide whether you want to use it, test it. And again, if you have always a few questions, I'm happy to answer them. I'm pretty passionate about that project. I came up with that solution back in 2009, built a full product around it in 2015 using a custom DSL. And then when I started to work at Nav, that problem came back, and the engineering manager decided to give us the resources to solve it. So I was really excited about that. So I'll keep the conclusion for after the code walkthrough. Any questions so far, or concerns, or no? All right. So I'll there's the chat. Okay, no. Refreshing to see backend system with no Java. Yeah. Absolutely. But to be honest, for me, there is only one language. It's called JavaScript, but I'm a little bit extreme. Let's see. All right, let me share my VS Code. Everyone can see it. All right. So here's the project. Again, nothing earth-shattering. We have in the main file the orchestration of the code generation. So it's pretty standard. Nothing again. We're just going to go read our schemas, read the message definitions that I will show you in a second, and then look at all the languages that we have to generate. This is configurable, so you can add or remove languages based on what you need. It's nothing too complicated. And then the generated code is generated in the output directory. We'll take a look at that. I really want to emphasize the work that Michal Sainski has done on the build pipeline, because this was a very hard problem to crack. So what we're doing is in our build pipeline, of course, we starting a Docker container, we generate the code there, and then we check the code back in our repository. But that process is actually quite difficult. And even if you never use this project, you might actually, if you ever build something that is low code or no code like this, you may want to take a look at this build pipeline, because I have some friends in the model-driven engineering community who are experts, who've been working on model-driven software for decades, literally. And I asked them, oh, by the way, how do you check back in the code, the generated code? How does it work? Did you have something? And basically the answer was no. So, and then when I saw the kind of work that Misha has done, it's amazing. So if you ever build a code generator of some kind, I would definitely take a look at the build pipeline here, because it will solve that problem for you, again, in a very elegant way. So just keep an eye on it. So let's go back to the project itself. So, there's a few libraries. I don't know if you guys have ever used the GraphQL parser that comes with GraphQL tools. It's not the best, I could say. I hope it's very useful for the engine itself, the runtime engine for GraphQL. But otherwise, when you're trying to extract metadata from the schema or the queries, the GraphQL parser is very annoying, very, very annoying. So what I've done here is I built a little wrapper around the parser, the GraphQL parser. It's it would tell me if something is an enum, an array, etc. So you don't have, your code doesn't have to worry about looking at the parse data and try to make sense of it. I'm not claiming that's the best or cleanest way to put a wrapper on the parser, but it kind of works for me. I was able to get everything I need from it. I use a Ramda. I don't know if you're familiar. It's something like Lodash. It's proved very useful in that case, because there's a lot of functions, to extract the data, the metadata from the DSLs, and so anyway, you don't necessarily have to look at that code that much. All this information will be provided to you in the code generator. So if you write a new code generator, you don't have to think too much is where is my metadata, because it will be given to you at the time you need it to generate the code. There is kind of the usual suspects for util, nothing, again, earth-shattering. You don't need to take a look at it. I think it's pretty much standard. And then this is the generator harness. And so again, this is standard for all generators. You can take a look if you're interested, but there is not much to it. What you have to understand is that because the query defines the payload schema doesn't exist. So I use the query and I create a type associated to that query, such that, you know, after that I can generate the code from it, because that type doesn't exist like a standard data type in a schema. And so there is a first step in the harness that is take the query, create a type, a synthetic type that doesn't exist anywhere, and then use that type to generate code with the corresponding directives when needed. And of course, directives are passed to you at generation time, so you can just increase the type of directives that you use. It's irrelevant. You don't need to change the code. It's only in the code generator. And then you would, like, some people have asked the question, what do we do if we want to implement a validation rule that includes a range? Well, you just add a directive associated with min and max, and then you can generate code associated to it. It's just we don't have a lot of uses for ranges, so we don't have that. So now let's take a look at the generators. So the generators are basically defined in the main file. So a little bit of metadata, and you can comment or add new generators. So the harness will just look at this little configuration and generate code from it. Everything has been parameterized, so you can easily move things around as needed. So no difficulty there. And then, well, let's take a look at the Golang generator. So, so as you can see, this is about 280, let's say 300 lines of code. Nothing really earth-shattering. It's all JavaScript templates, template literals, and all the metadata and is coming here. So it's generally pretty easy to write this code. Once you kind of get your way around the project and you understand the metadata. But if you're very familiar with GraphQL, all this would look very familiar to you. It's nothing that would be difficult. I would say that maybe the biggest difficulty is to generate code that integrates with your production code directly, and that's what we have. It took us, a few weeks to tweak things here and there in Ruby, Python, Golang to remove all the errors that we would get once we link this code to our production code for validation. But now it's completely stable, and we've not looked at it. We just added the protobuf in the last 6 months, and that's about it. So as you can see, we're generating where's enums, so what is an enum? And that will be called by the harness if it needs to generate an enum. Then we generate types and the corresponding validation associated to it. And all the generators look the same, right? You go to Python, so you will have the enum, same thing, and then you would have the the corresponding structure def that is called by the harness right here. So you would have more or less helper functions to help you generate what you need. And as you can see, Python is a little bit bigger, but it's a very verbose language. So it's about a little bit more than 300 lines of code. Same thing for Ruby. We have the same functions that are called by the harness, and as you can see, it's about same as Golang, almost by the number. Interesting. And then we have json-schema, which is a lot smaller, but it generates the valid json-schema based on that. So it's about 200 lines of code. And then protobuf, which is also a little bit less than 200. But this is not a language per se. This is just an IDL, an interface definition language. So it doesn't have a lot of generated code. It's pretty much schema to schema transformation here. Same thing for JSON schema. So any question on the generators themselves, or no? So now let me show you what it does. So how it works. So we have our data schema, typical GraphQL schema. We use scalars for further validation. So using regular expression. So of course you have to write the scalars in different for different languages. There is also some specific class that we would use, like for the time, etc. And again, regular expression. There's also the conversion of GraphQL types to the native types of the language, but nothing, again, out of the ordinary. It's super simple, and all this now becomes, validation. We do have some concepts related to that are specific to the language. Like what class we instantiate. There's also some imports that I think it might be in Ruby. Where is it? No. Go. Import. It's in protobuf. So if we want to add an import to the generated code, then we would have it added to the scalars. So and all this becomes available in the code generator. So that's specific validation rules, and as you can see, everything else is completely standard XML. Sorry, GraphQL. We use the query type to define the payloads. So this is the payloads. Like for instance, the profile here is a payload. And again, it's a standard GraphQL query, and that instruct the code generator what to do, which file to look for. If you don't put it in the query type, then it's ignored. That's kind of the basic foundation. Otherwise, again, it's a standard GraphQL query, just a little bit of directives that you would not necessarily have if you were using the GraphQL runtime. And again, order is only there because of protobuf. You don't have to use the order directive for the project when you use any other language. And then what do you get? Well, you get this. You get, let's say, validation rules. So this is Golang. Again, nothing very surprising, but it's clean code, simple code, and the beauty of it is now if you go to Python, you send some JSON between Golang and Python. Now you have the corresponding validation rules in Python that match, so that you never have, if one side believes it's valid and the other doesn't, that cannot happen, unless there's a bug in the generator, but they never get out of sync. So now you have a robust infrastructure architecture for validation rules, payload validation. And it's also, a lot of it is self-standing to avoid a lot of dependencies, that can be a problem. For instance, all the JSON schemas are completely self-standing with no imports. And that's, yeah, it's, sorry, there's a problem in the scalar. And this is a, 100% generated, no manual intervention. We don't use a JSON schema, by the way. We use only Ruby, Golang, and Python and protobuf. But JSON schema can be used for the JavaScript or other languages that you don't want to build a generator for. And that pretty much it. That wraps up the presentation of the project. Any question on it? No? It's pretty simple project. It took us a few weeks to build. I started to build the prototype on a snowy day, a snowy weekend in Seattle. Had nowhere to go, so being at home, just put up my computer and started to code. Showed Brand, our manager, the result, and then from that point on, this is what it became. So let me go back to the conclusion slide. So in conclusion, the management of payload validation is a hard problem. And I think a lot of teams choose to ignore it and just live with the danger of not validating their payload too much. Here, you have an opportunity to take control of that problem and then go back to a mode that I think is the right mode for designing microservices, which is contract first. You can think of the contract, you can design the contract, and then pass that code down for implementation. And it also provides a really good foundation for data management, because here now you have and that's the beauty of GraphQL, you have a consolidated view of your enterprise data model. But this is different from GraphQL. The GraphQL enterprise data model is more focused to the front end. This one is related, but not exactly the same. It's really the enterprise data model of the backend. And so there is a real opportunity here to align the two more effectively than having just API developers who just build stuff and the front-end team who eventually stitches everything together via resolvers and whatnot. So there is an opportunity to clean up the mismatch between the backend and the GraphQL layer. And B, there's also an opportunity to manage your physical data model much more effectively, because now you have a single place where it is defined and managed. And so it should yield some benefits there. So as I said, we've been running in production for about 6 months, a little bit more now, I think. Let's see, April, yeah, maybe seven months. And it does the job. It does what we expected it would do. And I see merge requests all the time for new payload definitions, additions to the schema. We do support extensions, so that's something that I baked in because for me, type extension are really essential to the health of a microservice architecture. And so that was really part of the design from the beginning. And that's it.
Cool. Thank you, JJ. So there was a question here.
Okay.
William Slater, were you an Erlang programmer prior to learning Golang?
So I'm neither Golang nor Erlang. I'm a JavaScript programmer. If it was just me, there would be just one language. It would be JavaScript and nothing else. But it's extreme. It's all right. It's okay. I believe that, but I understand that people say, "Huh, what? This guy is nuts." It's okay. It's okay. I just like the language so much. I started my career with Objective-C in the 90s. And I did a little bit of Pascal before that. I'm an old guy. But I started my career with Objective-C. And for me, dynamic languages have always been something that I cherish. And JavaScript has pretty much everything I like about a language. And it has an extensible data structure at the core, JSON, which, when I see what Golang does to JSON or other statically typed languages, I'm just horrified. I feel sad for the other developers. They live in this dark room and never see the light of extensibility. So.
The next question is, how do you feel about TypeScript?
TypeScript, I don't feel good about it. It's okay because it doesn't prevent me to use JavaScript. So I feel okay about TypeScript, but I don't need it. It's just, if you want to understand, my career has been built on extensible data structures, even with Objective-C. There is, I had this haha moment in the early 90s about having very flexible code structures. And I built an Alexa system back in 1995 using, Objective-C, and it was jaw-dropping. It was not based on voice, because the kind of the voice capabilities, text-to-speech or speech-to-text, didn't exist in the mid-90s. But I had built an extremely complex industrial processing system, and the only way to control it was to define natural language rules. So I built that in Objective-C, and then I never looked back. It was like, okay, I developed a programming style that I could never go back. I could never go away from. And each time I hear class structure or something like that, I feel a little bit sad about it. But I'm extreme. Please don't, I totally understand that people will strongly disagree with me and whatnot. It's just, for me, the other part you have to understand is that in the last 20-25 years, I've worked in APIs. I was one of the first users of web methods back in '98, and B2B and business process engine and so forth. So the kind of handling communication between services, orchestration, it requires state management, and managing state is extremely complex. Actually, created a pattern called the SAM pattern back in 2016. And I created a JavaScript library for it. And extensibility is the key to state management. The problem of using, functional programming or object-oriented programming. So functional programming is going to couple your inputs to your outputs. So it's like, how do you manage really state in something that couples inputs and outputs of your programming construct? It makes no sense to me. Doesn't mean that functional programming is useless. No, you look at this code, it's full of functional programming, but it's used in a very specific capability. Now you look at object-oriented programming, and you say, oh, it takes state and it fragmented in all those little things, and good luck if you can make sense of it. It's like, and then there is another aspect is to use extensibility, extensible data structures to manage state, and then you can introduce temporal programming constructs. And for me, when I code, I use those three concepts where I think they apply: functional programming, object-oriented programming, and temporal programming. And state management is such a huge part of what we do. If you don't have the right construct and you try to do it with functional programming, object-oriented programming, is going to be 10 times, 100 times harder than if you do it with temporal programming. So those are the reason why I'm saying what I'm saying, but it's a position that's very hard to defend in the industry, because nobody knows about temporal programming constructs. People think that state management is hard, so whatever, we'll just bite the bullet. You look at Redux and all the things that happen around it, and people just went for it because they thought it was the greatest things under the sun. Then they got disappointed. They took it all the way off the code. I mean, state management is still not solved today because people don't understand temporal programming. There is no language where temporal programming is available. And to be able to implement temporal programming construct, you need extensible data structures. And for me, JavaScript has that. And you tell me, oh, TypeScript or Golang or exactly that, I cannot do anything with that language. I'm going to write 10 times more code than I should. It's going to take 10 times longer, and I'm going to hate it. So, but this is me. I'm a little bit extreme. I don't want. I respect other people's position, and they can tell me, hey, you're just an old fool. You don't know what you're talking about. It's fine. It's fine. It's okay. I just convinced myself enough to say, all right, I have some code to write. I'll just choose at each time, each part of the code, whether it's functional, whether it's object-oriented, or whether it's temporal. And with those three things, I can usually build what I want.
Yeah, I think I'm pretty much in the same boat. Anyone else have any questions? Get unmute if you want.
Ron, yeah.
Oh, we got a big one.
Yeah, you mentioned something about temporal constructs. That's something I haven't heard of that much actually within the software programming area. But I'm just curious as to if you could. I mean, this may be a whole topic for a whole nother discussion, but what exactly do you mean by that? Do you mean by having a language that directly supports asynchronous issues, or is it dealing? I'm not exactly sure what you mean by temporal constructs.
So there's a whole branch of computer science called temporal logic of action, but unfortunately, it's kind of very academic, and it's usually very hard to translate all those research paper into like practical code. So I spend a lot of time doing that. I had the luck to talk a little bit to kind of the god of TLA, is Dr. Leslie Lamport. Some of you may have heard of him. He contributed to a lot of things in the industry, especially clocks. He's the one credited for helping synchronize clocks across computers and whatnot. He's an incredibly smart person. I mean, it hurts how smart he is. But he's also very academic. He just thinks at a level that is not where developers would want to work at. And so I tried to read the best I can his work, and I translated it into coding patterns that implement temporal programming constructs. Nothing earth-shattering. The temporal logic of action is not very complex, but it provides some structure you can use in the code. And basically, I put all this structure into a pattern that I call the SAM pattern, the state action model pattern. So a lot of people actually will see, oh, but that looks a lot like Redux. In many ways, Redux reinvented temporal programming, but they never understood that this is what they were doing. And therefore, the advice around using Redux was never right. People just crammed everything into the reducer, and that was a complete mistake. It could never work, and once if I tried to talk to Dan back in 2016, but he was already a star, and he just didn't want to, I don't know, he didn't want to engage in any kind of conversation. And eventually the Redux people got mad at me, and they even created a GitHub page to where they listed everything I was saying for the record, and I'm happy they did that, because for the record, I say Redux will be abandoned, and it has been. But it's a shame that it has been, because it was well designed. It's just the advice around it was not very good. And people using it would go immediately into a dead end, because they were not understanding how all the parts of Redux could be used, and should be used, because so that's a little bit unfortunate, but that's the way it is. So, but at the end of the day, state management is still a problem. It's still hard to write code for state management, application state management, or orchestration, etc. And eventually that problem will have to be solved. We cannot just say, hey, look, it's hard to write, let's bite the bullet. There has to be a better way. And what I'm suggesting is, hey, look, there's this whole thing called temporal logic of action. Take a look if you can, and then try to build principles to write your code, and you will see that it makes a real difference.
So are you talking about, again, it's like dealing with asynchronous external events, and so are you thinking of something where you merge, or like JavaScript has the promise, or the async wait, and other languages have stuff like that? Are you talking about merging that with a mechanism to manage states and manage state transitions based on external asynchronous events?
Yeah, so most people would identify temporal programming with state machines. They would say, oh, okay, what you're talking about is just a state machine. And yes, it's just a state machine, but what people don't understand is that Dr. Lamport created a structure of state machine that is completely different from what we all know as a state machine, and we don't use, because state machines are, and everyone who's tried to use state machine has never been really happy with the end result. And Dr. Lamport actually, during his I think PhD or very early years, he demonstrated that basically like Petri nets and so forth were not enough. They were interesting construct, but the theory was so limited that there was a problem with it. He didn't know the solution, but he spent the following 20 years building the solution to find kind of the next structure of state machine, going away from Petri nets. And so that's basically what I based a lot of my thinking, for the last 5-6 years since I discovered his work, and finally had this haha moment. Hey, look, there's functional programming, object-oriented programming, and temporal programming. You cannot just say one is better than the other. One is useful, or the three are useful together, or depending on what problem you're trying to solve. And so that's kind of where I am right now. But at the core, it's very hard to implement state management without an extensible data structure. If you use types, it's going to be very difficult. And that I discovered way back in the 90s. That's why I fought so hard with XML-schema, trying to keep extensibility open, and so forth, because it is such a jewel, such an advance to programming, that I'm so shocked that a new language like Golang, for instance, doesn't have an extensible data structure at the core. It's like such a nonsense to me, that it hurts basically to have spent all this effort, to have all those smart people, incredibly smart people, building something like Golang, and then the first thing they do is they cut the most important advance in programming in the last 30 years, basically, which is an extensible data structure. So that's kind of my belief. Now I'm happy for people to disagree.
Do you think the problem gets solved by defining some sort of new language, or is it something that can be solved with just frameworks and maybe extensions to existing languages?
So I wrote a library. So the extensible data structure is something hard to solve if the language doesn't have it. It's very hard to solve in Java, Golang, you're going to suffer. So that's why I love JavaScript so much. It's like it's such an incredible language, not just for the extensibility part, but it's just smart. As like I get amazed a lot of times with it. But yeah, it might require to create a new language, that has temporal programming construct at its core, and then find this balance between functional programming, object-oriented programming, and temporal programming, just like JavaScript is doing. It's not trying to tell you, hey, you should be functional, or you should be object-oriented, or you should be this, or you should be that. It's basically, hey, look, programming is flexible, and depending on what you're building, you're going to need, to kind of get all those constructs play nicely with each other rather than opposing each other. And that's what I like about JavaScript. It has this tendency to help concepts play together rather than against each other.
Can you give me it sounds like I'm monopolizing the group here. Can you give me a quick or simple example of what a temporal construct would be, and a simple example of how you would use it? So
what you have to understand at the core is that the state machine that Dr. Lamport invented is a code-based state machine. It's not like state as in Petri nets, or like the state machine we all have in mind. And the constructs in it involved some simple rules, like separating, isolating mutations. In other words, once you do that, it becomes a lot easier to manage state. And this concept of isolating mutation, say compared to assignments, is part of the toolbox of temporal logic. Other than that, there is some operators, and the way I translated it is as a pattern. So it's not because I couldn't create a language. I didn't have the resources, the time, etc. So basically, what the pattern says is that because you need to isolate mutation, and that would be the equivalent of the reducer in Redux, just to give you a thing, then what it means is that you need to create a proposal to mutate something. You cannot just arbitrarily say, oh, I'm going to mutate here in my code. And that's what we see with the event handler pattern, where the event handler is basically a master orchestrator, whether it's MVC or etc. And this is what temporal programming will teach you, is that to go away from the event handler or MVC and say, all right, just slice your code in a different way. And, first it would be reactive. It would not be, just orchestrated and request response like a traditional event handler or MVC. And then the code you put in, say, just to use Redux words, to the code you put in the thunk, this is the type of code you need to put there. This is the type of code you need to put in the reducer. This is the type of code you need to put in the selector. And then what was missing in Redux, and what they tried to do with there was another library using function generators, I forgot, Saga. It was Redux Saga who was created because they realized very quickly that, well, something happens, after the selector, and you need to look back. And again, that's a temporal programming construct. But using function generator was ludicrous, because now you move part of the state management into the function generator. And now you can never communicate what is the application state, because some of it is in the function generator and some of it is in the state that is part of the reducer. So basically the pattern had really good ingredients. They had a really good intuition as to what needed to be done, but they never they basically never advise people and say, hey, look, this is what you put in the thunk, this thing. And what temporal programming will tell you is we will tell you clearly what you need to put in all those pieces of code. And by the way, don't use a function generator for what they were using it for, because that's not how it works, and so, if you want, I'm happy to come back and do a presentation on temporal programming, but at a high level, this is how it's structured. Is very close to Redux, but not quite, unfortunately, and the not quite just created the destruction of Redux rather than the emergence of temporal programming.
Okay, great. And you said Dr. Lamport published a paper.
LAMPORT. Yeah, like there is one paper to so Dr. Lamport, temporal or TLA plus. There is this paper, it's 20 page. Let's see. Here, I think this is this one. Yeah, specifying system by Dr. Lamport. If you can read this paper, you will learn everything about temporal programming.
Okay, great. If you could drop that link in the chat, I would really appreciate it. And I'm going to shut up for a while in case somebody else wants to talk.
I see another question from Dariush. Are you still there, Dariush?
Yeah, I'm here. Yeah, okay, just listening to the conversation.
All right. So let me read your question. I might be missing something from the overall architecture, but how does having a type foo defined in a GraphQL service X and generated some types forces my service Y to understand what foo is? So here it's really not about that. The way the architecture works is we have this common data schema that represent all the entities that your architecture is implementing. And sometimes different microservices will implement those entities. It's not necessarily as siloed as we want it to be. So there's no relationship between the data model in GraphQL and what the what is implemented exactly in the microservice. However, the payload that the microservice will receive will contain information, and they could do anything they want with it. It's not like you could receive customer data and not be a microservice that manages customer data. You just need to be informed that a customer state has changed, and you will do something else related to it. For instance, you could, in our case, download a new report or something from a credit bureau, and that microservice doesn't manage customer data at all. Its purpose is, hey, I'll go talk to Experian and get a report and then put it there, and that's it. That's my role. But I needed some customer data to be able to perform that operation, and therefore I'm going to expect a payload containing customer information, and I'm going to have to deal with it, right? And therefore need to validate it and so forth. So this is literally to help you create validation rules and say, all right, I'm going to expect this data to come here in my microservice, and I want to run those validation rules. And I don't want to write those validation rules because it's really annoying. If I have a large payload, I could have hundreds of lines of validation code to write, and that's too much. It's hard to debug. How do you make sure that all those rules are bug free? Like the advantage here is that the way it's expressed using GraphQL schema and GraphQL query is almost guarantees you that it's bug free. It's like it will validate what you expect it to validate.
Yeah, but it doesn't have like any runtime implication in the service. The service has to actually adhere to the contract that you're specifying in the schema, right? So if I change on my backend to have some other structure, I have to update my queries to match it. So there's no forcing function between those, right?
Well, if you wanted to, you could continue generating other things. Here, we just stop at generating validation code. What you're saying is you're saying, hey, look, I could use the entity definition to generate my database schema. Why not? You know, it's not, it doesn't have to stop there. This is actually a general code generation framework, you know, is based on GraphQL. That's kind of the key, is that if you know and love GraphQL, now you can reuse it for a lot of things that are not runtime related, and yet, you know, reusing all the information you can bake into a GraphQL schema and a GraphQL query. So that's kind of the value I see, is that, but there's a trade-off between controlling everything data related from GraphQL schema and the flexibility you're going to get. Here we stop at the payload definition because it's a well-bounded problem. And if now you say, oh, okay, now I received this payload and I'm going to make a query to my database to write the data, therefore the schema has to, you know, align with this and so forth. It's possible. It's not that hard actually, but it creates some constraints on how you see your entire architecture, whether it's really going to be that simple. You know, sometimes it's not that simple. Sometimes you receive a payload, you have a lot of stuff to do and query some other parameters somewhere else, and you know, and then you finally write something to the database. And what you write to the database may not exactly be shaped the same way as what you receive in the payload. So that's why right now we didn't go further. But there might be other, you know, other types of problems that where this is totally doable, you know, where it makes sense. But there's no runtime here other than once you take the generated code, that's what you put in your runtime. Yeah, I hope I answered your question. I'm not sure if the answer was satisfactory.
Well, so I don't understand your architecture. So basically that's where the confusion comes from. But I guess I could see where it could work. But at the same time, like the protos have like a pretty extensive validations that you can add through like Envoy proxy. They have like that you can annotate your protos, and that is actually a hard contract on the communications between the gRPC services, right? You generate the code from the schema, right?
But you can't use gRPC for create, update, delete. I mean, this is an anti-pattern. This is a total anti-pattern. I have no idea where Google is taking their ideas, but this is a total anti-pattern.
What anti-pattern for what? Could you repeat that?
Using gRPC for side effects for create, update, delete. This doesn't work. You know, it's. I mean,
gRPC is for remote procedural calls, right? So any messages that you can do.
Yeah. So, and protobuf is tied to gRPC, right? Is that's what we're talking about. And the problem is for a lot of queries, gRPC works fine. I don't like it, but again, that's completely personal choice, nothing. And I'm not even talking about runtime arguments. I understand why people use gRPC. Okay, the problem is using gRPC for create, update, delete. Anything that has a side effect is an anti-pattern. This was known back in early 90s. This was completely abandoned in the early 90s because it didn't work. It will never work. You will always fight again a lot of temporal conditions, because you know, making a synchronous call for doing a side effect is you know, only in a perfect world. And we all know, you know, the fallacies of distributed computing, and I'm not sure why Google thought they could go around it. It's you just can't use gRPC for any call that has a side effect. I mean, you can, but it's at your own peril. It's like if your data quality suffers from it, it's your problem. You have to spend now some energy to fix that. But we've known for 30 years that synchronous call for side effects don't work, period. I mean, it works if you have a user in the loop, so you make an HTTP, you submit a form, the user will say, oh, something failed, and the user will know what to do. But, or not, maybe they'll call support or whatever it is, right? Like right now, I have a credit card, and each time I open it, I see a message, we cannot display your data, try again. And I try again. I went there a few days and I called support and I said, what's going on? It's not very encouraging that a credit card company cannot display my data. But anyway, that's a different problem. But what I'm saying, with a user in the loop, you can deal with synchronous call because they'll know what to do. But with a system to system communication, trying to handle side effects with synchronous call is an anti-pattern. It has been tried for decades and it has not worked. So gRPC cannot be used everywhere. Protobuf cannot be used everywhere. And even if you can, you're still facing this optional required problem. It's absolutely ridiculous. Who can validate something with everything optional? Who? I mean, what are they thinking at Google? I look at the entire Golang architecture. It's scary. I have no idea how they could convince people to use Golang. I have no idea, to be honest. It's controversial. I'm happy for people to have a different opinion. I don't mean to have for everyone to use my opinion, but everywhere I look, I feel like Golang is a disaster. I hope there are good reasons, for using Golang, because I don't see any. I mean, even the compression factor that you get is questionable. There's only a small window where it really makes sense. For large payloads, you can use gzip. For smaller payload, it makes no difference. So what's the point?
I disagree. There is a significant performance improvement of using a binary protocol like gRPC over gzipped JSON, which is human readable. So the size might be the same. You're gonna lose time trying to deserialize it to actually unpack it. The performance throughput of doing like gRPC calls is just, as your payload increase, is gonna be much faster. That's why for the backend systems you would use gRPC. But for something that's the gRPC is not for the front ends because it's browsers cannot communicate with it easily. But there's a very specific use case for gRPC for low latency, big distributed backend systems.
Sure. I'm not trying to convince you. It's just everywhere I look, I couldn't find a light on Golang. But I'm not trying to convince people of my, because I know it's a losing argument. People like you come and say, hey, this is X, this is, yeah, maybe, I don't know. I didn't do the measurement myself. I read a detailed article explaining why what you just said was not correct, but maybe you did the measurements yourself, and that's good. But everything I've seen about Golang gRPC, for me, makes no sense. But I'm not trying to convince anyone. If you're happy with Golang, then it's fine. I'm not going to be the one saying, hey, look, never use Golang, this is silly or whatever. I don't know enough to make a completely definite argument, but everything I've seen so far, not even one detail, leads me to believe that I should use Golang.
Well, you don't need the Golang for the gRPC, but that's
sure, yeah. gRPC for me is like anything RPC is an anti-pattern. So I would not. You have to convince me really hard with very definite arguments to say oh yeah, let's use an RPC interaction model. It's just not so. But look, I don't want to make it like a debate. I'm just trying to express my opinion, and it's an opinion. Maybe it's a silly opinion, maybe it's an uninformed opinion. Granted, I'm not trying to say I know everything. I've tested everything. I've done like a deep comparison between the two. It's just I've been in this industry for 40 plus years now. If you count when I started writing my first line of code, and everything I've seen there is not appealing to me. It's the opposite, actually. But I may not have faced some problems that it's good. It's a good solution for. It's fine.
Cool, cool. All right. Any other questions? Otherwise, I could take it off recording and cool. And we could